Okay. Okay, just for those that have joined a bit later, good afternoon, everybody. My name is Paul Carey. I'm going to give a demonstration, hopefully this afternoon, of how we can carry out some CFD, basically using DesignBuilder, and look at using the link to EnergyPlus and how we can use that to look at a natural ventilation model. What I'm going to do is I'm going to go through a fairly simple exercise, carry out a fairly simple natural ventilation model, carry out some simulation using EnergyPlus, and then I'm going to use the link between EnergyPlus and the CFD module to import data from one to the other, and then we'll be able to look at the actual flow throughout a room using the CFD element. And how we can get some graphical output and how we can use that to analyze our buildings. Now, obviously, it's going to be a fairly simple overview in terms of what we can do, and so just so that we're not running a very detailed analysis, because obviously this is a webinar, and we'll make it quick and show everybody the functionality. If you've got questions at any stage, please don't hesitate to ask them. If we can answer each question straight away, what happens is it tells us that we haven't answered your question, the software here, and what will happen is we will then answer your questions by email afterwards. So please do just try, if you have got any questions any way through, what I'll try and do is try and answer them as we're going along. If I can't, what I'll do is we'll make sure that we answer them as soon as possible afterwards. Okay, so what I'm going to do is, hopefully you can all see the start page that I've got. I've got my front start page of DesignBuilder, which is showing me my job files. Now, hopefully most of you are fairly used to using or have at some point used DesignBuilder, so I'm not going to run through everything with regard to making a model and everything. I'm just going to assume that you've got some experience with using the DesignBuilder. What I'm going to do is I'm going to create a new model, just so that I can look at creating this simple natural ventilation model. So first off, I'm just going to start a model, and I'm going to use a default model. I'm just going to call this webinar, just so that I know what it is, and I'm going to use the London Gatwick weather data. Now, I could have obviously used this anywhere. I'm going to make sure I've got my EnergyPlus data, and I'm just going to press OK. So I'm going to start this new model, and I'm just going to literally try and create a fairly quick model, as I'm not really going to go into too much detail of creating a very complex model. So what I'm going to do is I'm just going to create a new building, and it's going to be, unfortunately, a very, very simple building. And I'm just going to create a simple square box model. The idea here is to show the functionality, obviously. So I'm going to take my block. I'm literally going to create a box on this model, and I'm just going to create it 7 meters in this direction, and I've got to make it 10 meters in this direction. And then I'm just going to literally just finish that block off and make a standard rectangular box. So I've extruded it up. So what I'm then going to do is I'm going to then look at the various settings that I need to make and start building up an EnergyPlus simulation. So I've got a few settings that I obviously need to look at in terms of this model. You can see I've got a fairly rectangular model with 4 windows on it. Okay. And what I'm going to do is I'm just going to go through the settings and look at what I need to set up. So if I go to the Activity tab, this, as you can see, is set up as an open office. It's an open plan office, and it's got set up so it's got set occupancy schedules, etc., from the templates already. The one thing that I want to look at on this particular thing is the metabolic rate. This will be useful when it comes to the actual the CFD comfort analysis that we do later. So it's important that we look at that, and in this case, it says it's a light office work, and we can look at our clothing values here, and we can use that when it comes to our later Fanger analysis. But just to make you aware that that's where that information is. We can then go to our construction tab. Now, one of the things that you can see on here, apart from obviously our construction data, the various constructions for the various parts of the building, is that we've got the infiltration. Now, infiltration obviously is building fabric related, and in this case we could see it's actually a scheduled rate in this case. Now, what we need to do in terms of for looking at the actual flow through the window openings is that we need to set this model up instead of a scheduled rate, as this is purely a scheduled ventilation case. What we need to do is we need to go to our building model options tool, the spanner icon, and we click on that spanner, and what we can then do is we can see under the data tab that we've got right at the bottom here under natural ventilation, we switch from scheduled to calculated natural ventilation. Now, this is the way that we want to use it. Rather than using a scheduled rate, what it now does is you can see here it says natural ventilation and infiltration airflow rates calculated by opening and crack sizes, buoyancy and wind pressure. So basically it looks at the external wind data and calculates the flow through the openings. So I'm going to press OK here. It will come up with a warning as to whether I want to use compact HVAC. In this particular case, I'm not interested in that. I'm just interested in calculated natural ventilation. So in this case, I'm going to press no. You'll now see that that changes the construction tab slightly, in the sense that this constant rate that it shows is now only for heating and cooling design. As it says here, design only. The actual infiltration is dealt with on a template basis, and we can change that according to how good our infiltration is, whether it's a very leaky building or whether it's an airtight building. Now, in terms of our openings, in terms of the actual windows now, what we can do is we can go to our openings tab, and you can see that we can obviously detail the type of glazing and stuff, the type of glazing that we're actually going to use, and the dimensions, etc., not only for our external windows but also internal windows. But what we can see is that there's no control on that at the moment. If I go to the HVAC tab here, we can see by default this model has been built with a fan cooling unit. Now what we're going to do is we're going to look at a natural ventilation case. So I'm just going to open this slightly up, and if I click on the right hand side on this template type, what I'm going to do is apply here a hot water radiator heating and natural ventilation. So I just double click on that template type, and you'll see now that that has applied that template data for that HVAC system to the model. You'll see that I've got no mechanical ventilation. It's heated, it's provided heating via a natural gas boiler system. But what you can do is, if we come down here, you'll see there's no cooling on, but the natural ventilation option has been switched on here. If I go back to our openings tab now, you'll see now, because we've switched natural ventilation on in the HVAC tab, you'll now see that we've got this menu selection for operation. This allows us to set up the opening area on the windows. So now what we're doing is using the windows to actually calculate and to actually ventilate the building. So it allows us to look at that design, and look at how much opening we have in our windows and whether that's going to maintain comfortable conditions for the occupants, or whether it's going to provide adequate fresh air. So what we can do is, in this case, I'm going to leave it at the default. So you can see here we've got a glazing area by default at 5% of the opening of that window. So 5% of the opening of each window will be allowed open for natural ventilation. So what I'm going to do is I'm going to carry out a simulation on that building. So very simply, we've got this building. It's got 5% opening. It's got natural ventilation system, and what I'm going to do is I'm just going to switch on some options that I need to carry out in order to make sure that I can look at that both in an EnergyPlus point of view. I can look at the actual output data from EnergyPlus, but also I can carry that data through into the CFD. So I go to our Options tab here, and I go to the Store Surface Output. Now we're gonna check a few boxes here. So I'm going to check the Store Surface Output. I'm going to check the inside surface temperature and airflow in and airflow out. So those are the ones that I need to check. I could check additional ones here if I wanted information on these things. You know, solar gain sometimes, surface gain, perhaps solar incident gain could be interesting sometimes, but they're not important in terms of the simple exercise that we're going to carry out here. So what I've done is I've added that information to the model, what information I want to carry from the simulation, and then I'm just going to carry out the simulation. So I go to the bottom of my screen here, and I'm just going to click Simulation, and you'll see that it opens up our simulation box. So in this case, what I want to do is I want to carry out a summer typical design week in this case. So I'm just going to carry out a typical summer week so we can look at how the temperatures will be affected in the summer and what the temperature distribution in the room might be. So I'm just going to call this Simulation 1 just so that it gives it a name. And then I'm going to select Summer Typical Week from this box on the right. You can see this puts in our data. And in this case, in for CFD results, in terms of being able to carry out CFD analysis, I need to select the hourly. I'm just going to select hourly. It's quite important that we do, because obviously it looks at taking that data from the EnergyPlus calculation and it references that into in the actual CFD calculations. So I'm just going to leave everything else at default, and I'm just going to run this simulation. Hopefully it won't take too long. And you can see that it goes away and puts that model into EnergyPlus. It's loading the weather data there, and it's processing that model, and hopefully it just carry out some quick simulations. It's only a single room, so it shouldn't take too long. Now you'll see that it says update data. The reason for that is that if you look to the left-hand side where I've got my screen here, we can see that on the daily, what I need to do is I need to select hourly data. You'll now see that from my zone, I've actually got a description. I've got a fuel breakdown at the top here. I've got some information on the actual temperatures both externally here, and you can see the internal temperatures here. You can see the air temperature here of the room, the operative, and the radiant temperatures. So you can also see here a heat balance for the actual room. Okay. It also seems that for a particular period we've got some heating requirement actually, and that must be due to some overcooling at one point. And you can also see here the natural ventilation and mechanical and infiltration. So largely in this case it will be natural ventilation and infiltration that's causing, particularly this sort of non-standard, it's not like a steady profile. It's quite a rough profile here. So you can see that we can do that for the building level. Now what we can do is if we go down into our zone, and I'm going to just open up this this tree here so that we can see the actual openings. Now because we've simulated and stored some of the opening data, what we can do is if I look into the opening data now and I select one of the windows now, you can see that I've now got some information in terms of I've got the inside surface temperature, which was one of the selections that we made. And you can see that I've got that data, and we can see how that tracks the external temperature. We can look at some of the solar transmittance here through the window, but most importantly, the thing that that I'm most interested in this case is looking at the airflow in and out of the window. And you can see in this case we've got some airflow out. Now, it's quite interesting and quite useful in this case is if we go to the Detail tab, and if I select the Detail tab, you'll see that I can now add additional, I can choose what information I want to add to this. So what I'm going to do is I'm going to scroll down our list of information here, and you can see it's quite an extensive list of information. If I scroll right to the bottom, you'll see that I've now got site weather. Now, one of the things that I'm going to add to this is wind direction. And if I select the wind direction and then I select the save options for future use, now I could call this opening data, opening info perhaps, so that it tells me what template this is. I'm interested in seeing, you know, so I've got the opening airflow in and out, but I've also got the wind direction. So I'm just going to press OK to that. And you now see that I've got the wind direction shown here. So what you can see is in this particular case, I'm on the east wall, and I'm actually looking at the airflow out. Now we can see that the wind direction here is southwesterly, so a direction of 200 here, and you can see it's roughly 200 around here. So that tends to indicate it's southwesterly, and this is an easterly wall. Now if I look at, say, the south wall, you'll see that on the south wall, the 180 wall here, that the airflow is largely in. So we can see the airflow is largely coming into that room. If we look at the westerly wall, again, although we've got a bit of bidirectional flow, there is a large amount of air coming in. But it's most noticeable on this one that the airflow is in quite pronounced in this direction on these 2 days. If I then look at the north wall here, you can see that the predominant direction of flow here is airflow out. And I think it's quite important to pick those sorts of details out. So we can actually show that even within EnergyPlus. We can look at the bulk airflow and look at the situation and look at what is predominantly happening. So even this information could be relayed and showed what the typical situation is, over a week or, over some typical days. And in the UK, where that might be the predominant wind direction, then that would be quite an important thing to highlight to people. But you can see that we've got this information in the model now. So what we're now going to do is we're going to try and take that data, and I'm going to try and show you how to take that data from EnergyPlus. That data already exists now. It's in the simulation. We've carried out that simulation. It's already stored in that model. So what we want to do is we want to look at that information and we want to carry that into our CFD model. So what I'm going to do is I'm just going to go back to my edit screen, because now I'm interested in looking at my CFD model. I've already carried out my simulation model as far as I'm concerned for this exercise, because it's carried out the simulation and it's now a matter of taking that data into my CFD model. So the way that I can do that is that I can look under here under the Tools option, and you'll see that I've got something where it says here CFD boundary conditions. And so what I want to do is I'm going to open that dialog box, and you'll see that I've now got I've got a new dialog box which tells me I've got my boundary conditions, and this shows me the flow conditions for the various rooms and the temperatures. Now see, by default I've got a number of temperatures, and it uses a default temperature for both windows and for walls, and it also uses, we can see we've got no flow in and out by default. So what we want to do is we want to take that information, we want to bring that information in. So I'm going to import, I've got a button here or down here. So I'm going to import, select that box, and it's asking me today what data do I want to import into my model. So I've got some hourly data, and our previous results, it was the 2nd of July, and I'm going to take 12 o'clock on the 2nd of July, which was one of those days where we had the flow in a southwesterly direction. So I'm going to take that particular time and date and press OK. Now you see it comes up with a number of data items copied into the CFD boundary, and there's 10 items, so it's copied a lot of data. Now one of the things that you'll see now is that we've no longer got the default data. You can see that it's now applied different temperatures to the various boundary, various wall constructions, etc. You can also see that it gives us our zone air temperature, and you can note that that's 27.1 degrees. Okay, so the average air temperature is 27.1. If I look on the flow balance screen, you'll also see that we've now got a number of flows into and out of the room. Now this is taken from that particular time of the simulation, so it's a snapshot in time of the flow conditions. Now you can see that there's these numbers are quite different, and we can see that on our on our east wall, we can see as we saw in the graph, our flow was predominantly out. And again from our north wall, we can see that it's predominantly outflow. You can also see that we've got an inflow, strong inflow in the southerly wall, and then we've got a bit of in and outflow on the west wall, as we saw in the graph. Now what I'm going to do is I'm going to select that west wall. In terms of the actual CFD solution and the simulation, we have to have what we have to have is continuity of mass flow. And it's quite important that we have that in order to be able to actually carry out the CFD calculations. Now, you can see that there is a slight imbalance in the actual flows. Now, sometimes when you import information from EnergyPlus, that can, as it has in this case, lead to an imbalance. Sometimes that is increased when we have infiltration in the simulation. It's not essential that you switch off infiltration, and it certainly won't mean that it guarantees that you'll get a balanced flow. Sometimes it can lead to a smaller imbalance, but it's not always the case. But what we can do here in this case is that we can select a particular zone, and what I'm going to do is I'm going to select this particular wall, and then I've got a button here saying where it says correct balance using selected opening. And what that does is it just, as it says here, it increases my flow in particular, in this case in the outflow, by the required amount. So then you can see now we've got no imbalance in flow. I'm going to press OK. I'm happy with those zones and importing data, so I'm going to press Save. So I've now got that information imported into our model for our for allowing us to carry out some CFD modeling. Now what I can do is, if I look on the wall here and look at this particular wall, if I go to a CFD tab here, the CFD, you'll now see that that information has been carried into our model. You can now see that the inside surface temperature there is 32.97 degrees. Okay, so you can now see that that information has been stored into the model. Now what's also important to show here is that we've also got an aperture position. Now that aperture position is relates to where the opening on the window would be. So obviously if it was a top hung window, then we would have to use an aperture of bottom. Okay, if it was a bottom hung, or if you had, say, a fixed pane and then a top light, an opening top light, then you would use the top light. Now it's important at this stage to note that whilst we have the ability here to change this opening area, and there is a default value for that. But what we can do is, obviously we can if I select our block or our zone, what I can do is I can change that value here, and I'm going to change that so it matches to our the opening area that we gave it in the EnergyPlus simulation. So I'm going to change that to 5% opening area, And what I'm going to do is I'm going to also make it a top hung window, so I want my opening to be at the bottom of the window. So you can see there I've made some changes to the model, and then I'm going to go back to my layout so I know where I am in the model. So now I'm ready, essentially, at this point to carry out some simple CFD simulation. Now, I can add information to, additional information to the model, and I'll explain that a bit later. But, at this page, what I want to do is I want to go into the CFD simulation. Now, if I wanted to carry out an external simulation of the flow around the building, I could do. I would need to be at site level up here to do that, and then I would press CFD. I'm not going to go into that because essentially the process is much the same as it is here internally. What I'm going to do is I'm going to go to building level, and then I go to my CFD. Now, because I'm at building level, it recognizes that, and it says, right, I've got an internal analysis. I realize that I'm inside the building. I'm interested in carrying out an internal analysis. So what I'm just going to do is I'm just going to give that solution a name, and I'm just going to call it CFD1. I'm going to use the default grid sizing here. Now that default grid sizing in this case is 0.3 meters, so we've got squares essentially inside of it, or cubes inside of this box, inside of this overall room domain of 30 centimeters in square or cubed. The grid line mergence tolerance here is basically a way of making a more uniform grid. What it can do is when sometimes there are very small grid sections, what it will do is it will merge those together just to make the grid more uniform. And it's important that we have a uniform grid because one of the biggest problems in getting solution is the accuracy of the grid, and the best way to do that is to have a uniform grid. So what I'm going to do is I'm just going to press OK. And what this does then is it takes us into a CFD, it takes us into the actual CFD module part of the software. And you'll see that on the right hand side here I've got some information regarding the actual calculations and the grid and various aspects of the CFD solution. Now what I can do is I can look at my CFD grid. So what I'm going to do is I'm just going to show you where we can edit that. If I go to the top here and it says edit CFD grid, again I've got the button over here on the right hand side as well, and if I press the edit button, you'll see that this is my CFD grid. Now I can modify it. I'm not going to in this particular instance, but as you can see, if I wanted to edit it, I can do, and I can change it in the various directions. And all I was to do is, if I wanted to change it, would be just to make a selection, and you can see on the left-hand side I can then change or edit it. I'm not going to in this particular instance because obviously I want to keep it quite simple. You can see that in the Z-plane we've got some very fine grid lines there. Now that's made because the flow, the 5% opening that we placed is around the bottom of that window opening, and so that is where we've got the some very thin grid cells. Now, to some extent, we could use grid merge to merge those lines, those grid elements out, but because that's where the flow geometry changes effectively, we can look at that. But what we can do is that we can look at the grid statistics. Now, if we were in an ideal situation, we would be looking for a max aspect ratio that's approaching unity, so approaching 1. But because DesignBuilder carries out some analysis of the grid internally, and it looks at it, and as long as the maximum aspect ratio is less than 20, it will allow us to calculate out. And so basically, it tells us that model will be okay to run. So I'm just going to press OK to this, and I'm going to press Escape just to get ourselves out of the editing and get us out of the editing grid. What I'm going to do is I'm just going to actually start up a CFD calculation now. And it goes away and it brings up a new calculation options box. Now I'm just going to open some boxes over here so I can talk about them whilst we're running the actual simulation. And what I'm going to do is I'm just going to select, here are residuals, in terms of what we want to actually see on this screen here. So I'm going to start a simulation. So this iteration here that is carrying out, it shows us the number of residuals. Now these residuals are essentially a measure of the amount of error in our solution. So as it carries out every iteration, it then looks at how big it calculates the error to be, or it estimates the error. And as that carries out these successive iterations or these guesses towards the solution, what it then does is it then places these on a graph so that we can see how that is going over time and how they're reducing over time. Hopefully they're going to reduce. The idea is that these residuals basically come down here, and at some point they'll get to what we call our termination convergence criteria. And in this case, what we've got that set at a value of 10 to the minus 5. So that means the error is very, very small. What we can do with that is we can look at these residuals and we can see whether they are as these are all going down, they're approaching convergence of a solution. So we'll be happy with that, the accuracy of that solution. What can happen is sometimes if these go up and they sort of make a marked up, or if they start sort of bouncing up and down the screen here, what we could then say is that it would be a divergent simulation. What that sometimes means is that it tends to either mean that the boundary conditions are incorrect or the grid is incorrect. So one thing to be careful of is obviously when taking in your boundary conditions, hopefully won't be that far out, because obviously you've taken them from EnergyPlus. The issue will be then in terms of, is the grid realistic, and is it a uniform grid? Is it a grid that's allowing the simulation to be, to make sensible, come to a sensible solution? Now, as you can see, these are all coming down, and these are now beginning to become quite accurate. Mass flow tends to be the one that I tend to watch, and it tends to be the one that's of the most importance, really, in terms of the solution. And you can see that this is coming down to 10 to the minus 4. You can also see that we've got this monitor cell. We can create more monitor cells, but by default we have one that's created in the center, and in this case it's showing the X velocity component. Now what that allows us to look at is throughout the solution, and it just monitors the actual what the value of that is in that particular cell. And what you can see here is that it's risen up to a value as it's made the number of iterations, as it's trying to iterate the solution throughout the domain. And then what it does then is it's come down, and you can see it's gradually coming to where it's starting to settle out. If this were to continue for a long time, what you could say is that solution is basically achieved convergence. Because if you get to a stage where this is actually fairly steady, you can be fairly sure that the actual solution is actually converged. You can see that we've also on this side here, on the left-hand side of this screen, we've got a number of options. Possibly the most important that you can see are the turbulence model. In this case, we're running a K-epsilon turbulence model. We can also look at the number of iterations that we want to run. So if we wanted to look at whether it was going in the right direction initially, we could say run it for a couple of hundred iterations. Make sure that it's all make sure that we're starting to see the solutions going down, and then if we were happy with that, then we could continue with it and run it perhaps overnight if we knew it was going to be a very large simulation, for example. So I'm going to pause this because this is pretty much settled out. I could run it until we got the point where this all comes down and we get a convergence, but what I'm going to do is I'm going to pause this. And you can see it now tells me the results are available, but the solution hasn't converged. I could, like I said, if I'd run a number of iterations, you can see I've run about 1,000 iterations here. If I wanted to run it overnight, if this was a complex job, I could do so just by using the resume button. But I'm going to close this, and you now see that I now get a different screen on the right-hand side, and this is now allowing me to look at the results that we've achieved with this particular domain and solution. Now, what I want you to do first off is to look at, well, what results do I want to actually look at? Now, I think it's fair to say that perhaps the thing for a summertime situation that we're going to be looking at is we're going to be looking at temperature and comfort, and how people are going to be comfortable in that particular job. We're also going to look at natural ventilation. Because this is a natural ventilation job, we're also going to be looking at how the airflow is moving in that building. So what I'm going to first do is I'm going to go to here. If you look on the left-hand side on the display options, I'm just going to go to the slice settings. Now, at the moment, we've got it by default. It's set up as velocity vectors, so we'll see arrows with regard to the flow, and also then we've got field temperature contours. So we'll get basically a complete slice which is showing the temperature throughout that slice. So the way that I add that is I go to the Add Remove Slices here. And if I click on that, you'll now see that I have a green line that as I run across the model, hopefully you'll see it moving along, and I can then select a particular slice that I want to view. So what I'm going to do is I'm just going to take one particular slice, and all I do is I left click, and you can now see I've got some results, and it's showing me not only some, if I zoom in a little bit, you can see not only the flow in terms of the arrows and the directions, so you can see the flow in the various, you can see the flow coming in through the window to some extent here. We can see it moving around, and it's convecting around, and you can see also the temperature and the effect that that's having on the flow here. What you can also see, though, is the temperatures, and we can see that we've got quite a warm roof here. And we can see that the internal temperature here, and particularly at the middle of the room here, is around about 27.5 degrees, you know, this yellow region here. Now, if I remember back to our room average room temperature that was in the actual that we picked up in the boundary conditions import box, I remember that was 27.1. So that makes, you know, we can see that our average room temperature, you know, throughout space is 27.1, and as you can see in our sort of middle room temperature is, you know, in this region is around about the 27.5 degrees. So we can see that that is starting to correlate. If I wanted to add a contour, you know, slice in a different direction, all I do is I click on the left hand on any of the axis buttons here, and what I'm going to do is I'm just going to select that one in that direction, the Y plane, and I'm just going to take a slice again midway through the wall, and if I just left click again, you'll now see that you can see that I've got cold air. It's not cold air because it's still 24.85 degrees, but it's relatively cool, and you can see that I've got cooler air coming in here. You can also see we've got some air, and the direction of the arrows is predominantly in this direction. So you can see that we've got some air going out in that direction. But what I can now do is, if I wanted to, I could obviously add a Z-plane slice, and you can see now that if I've got all three there, I've got a fairly good description of what's going on in the actual zone itself. You can see that I've got flow going out in this direction here. I've got it coming in, sorry, in this direction by these windows, and you can see the zone of relatively cool air in that room. Now what I'm going to do is I'm actually going to switch that slice off. Now what I want to do, and to do that, is I basically, where it turns red, it means I'm on a slice, and I just left click again and it turns it off. Now what I can do is, if I was interested in looking at that area where it's a relatively lower temperature, I could actually plot that on top of this information. So what I'm going to do is I'm just going to press the escape key, and that takes me out of the add slice options. And what I'm going to do is, if I go down to the bottom of our display options here, you'll see that I've got 3D contours. Now what I'm going to do here is I'm going to turn on our temperature. Now if I turn on temperature contours, I then need to apply it. So I use the tick box on the left hand side here, and I press apply changes. Okay, and you can see that I've now got quite a complicated set of contours. Hopefully you can all see this. But what that is showing is showing the sort of it's the ISO surface essentially. It's where there's a change in the actual the area, which is that temperature. Now what I'm going to do is I'm actually going to turn a few of these layers off, these colors off. So what I'm interested in this particular case perhaps, is areas that are under, I'm going to look at the areas that are under 26 degrees. Now the way that I do that is I'm going to look at the variable settings here, and I'm going to select my temperature. And you can see at the moment I've got the range as is shown in here, it's 24.85 to 29 degrees. So what I'm going to do is that anything that's above 26 degrees here, so at this point here where it says 26.366, what I'm going to do is I'm just going to switch all of these contour bands off. And all I then do is click the apply. Now you'll now see that I've still got these contours and these contour slices shown, but I've also now got the areas where the influence of that cooler air. So essentially that's showing me the extent of the where that cooler air is coming in through those windows at the bottom of our windows, and how much impact that's got on our room. So we can now look at effectively the influence area of that ventilation. And as you can see, it's got a reasonable sphere of influence, but it's not affecting the whole room. Now, if obviously I was looking at perhaps a winter simulation, that might be quite useful, because obviously I could look at cold drafting, I could look at areas of where we've got particularly cold air coming in and causing discomfort. In the summer situation, obviously we're looking at more about getting the airflow in to keep the temperature cooler, and looking at the comfort effects of that as well. Now, what I can do is obviously I can look at this information and I can output it, and it's very useful in terms of actually looking at the flow and the regions of the flow. But what I'm going to do is I'm going to look at that, and I'm going to run a couple of extra calculations on the software. Now what I can do is I can carry out some comfort calculations. Now if I go to this button up here where it says Update CFD Comfort, and I'm just going to press on that. Well, that goes away and it does some calculations to carry out some analysis to work out, in this case, the mean radiant temperatures. But it also looks at the activity data. Earlier I showed you where on the activity data we had the information to do with the Fanger analysis, so clothing levels, etc. Now what this then does is it looks at that data, and what it's allowing me then to do is I can then start to look at plotting that data onto our CFD. So it obviously depends highly on the usage of the building and the setting that we make. So it's important that you set that up when you do set up your model. You set that actual comfort setting so obviously if you're looking at this, then it can carry out the comfort calculations correctly. But what we can now do is, if I go to my slice settings, I'm going to remove that data a minute in terms of the 3D. I'm just going to press None and apply it. Now what I can do is I can now, if you excuse me, if I look at the slice settings here, you can now see I've got a lot more options in terms of things that I want to add. So what I'm going to do is I'm going to turn off my velocity vectors and my temperature. And in this case, what I'm going to do is I'm going to look at my radiant temperatures. So I'm just going to select mean radiant temperature contours, and I'm just going to select filled mean radiant temperature contours as well. So this allows me to look at what the radiant temperature in the room is. So I'm going to add a removal slice. I need to press apply to make sure that that's what I'm applying, that data. And then what I'm going to do is I'm going to pick the Z plane. Now if I look at the temperature, say near the opening of the window, and I select that space. Now if I move that to this position, so looking in on top view, you can see now that my mean radiant temperature in the room, even in this central zone, is approaching sort of 34 degrees. It's a 34-degree region. Okay. Now you can see, okay, it's a little bit less in the area where we've got some flow, and it's slightly less around the windows, but we're still in the region of 32 degrees. So this room is really quite warm, largely because obviously we've got a lot of window opening, and this is a summer situation. So what I'm going to do is I'm just going to unselect that option. I'm just going to take that graph off, that slice off, and what I'm now going to do is I'm going to change that, and I'm going to look at PPD, percentage people dissatisfied. So what this is going to allow me to look at is to see whether people in this room are going to be happy with that environment. So this is quite obviously important. If I wanted to show this to a client, I could actually then say, well, this design is showing me that this is good or bad. And if I I'm going to take a slice roughly at sort of perhaps seated chest height, so about 0.85. You'll now see that if I rotate the screen here again, you'll see now the percentage people dissatisfied is up in the 84 degrees. 84%, sorry, 84%. So 84% of the people in that room are going to be dissatisfied with the conditions. So I think it's fair to say that we've shown that this design really doesn't work. But the natural ventilation obviously is there, but it's just not being able to maintain the comfort conditions. Now obviously that's to do with the the high temperatures rather than necessarily the actual ventilation. So that's one of the things that we can do with that. So we can highlight information like that to people in terms of actual whether conditions are going to be comfortable. One of the more recent sort of additions to the software recently is looking at the age of air. So what I'm going to do is I'm just going to press escape here, and if you look here, we've got calculate LMA. So I'm just going to press that button, and what this then does is it's going to calculate the local mean age error of air. So I'm just going to press start, and hopefully it won't take too long. It just carries out some iterations and calculations, and you can see it's finished, and I'll press close. Now what I can do is I can look at the age of the air. Now I can look at the age of air in terms of a slice if I wanted to. I could look at the age of air contours here, field air, and perhaps I might want velocity vectors. So what I'm going to do is I'm going to add a slice again, and we'll take a slice in perhaps the Z plane here, or actually we'll take it through the middle of the window here. And if I take a slice through the middle of the window, I need to update that. You'll see that, apologize for that, I forgot to update while I was actually showing. You'll see that I've now got the velocity, which is shown as the velocity vectors, but I've now also shown the age of air. So you can see that the age of air in this particular case, is just over a minute in these areas, so it's less than a minute here. But as I'm reaching up here, we're talking about it being approaching 5 or 6 minutes. In times here, it's shown as seconds. Now, that might be useful in this particular case, but what I would suggest possibly might be another way to show it would again here be age of air is a 3D contour. So again here, if I apply that, what you can now see is a contour map of the actual age of air. So if I press escape to come out of the add slice view here, you can now see that I've got some contours to do with the age of air. So what I could do is, again, I could go to my variable settings, and in this case I'm going to check the age of air ones, and you can see that this is my range of age of air. And what I'm going to do is I'm interested in where's the stale air regions. Okay, well, so what I would do is I would say, okay, let's switch off these bands where I've got relatively fresh air. Okay, and then I'm going to apply that. and you'll now see that I've taken it out, and you see this is the zones. So anything above these orange and red zones is essentially relatively stale air. Now, it's not particularly stale because it's only 5 or 6 minutes old because of the amount of opening area that we've got in the two lots of windows. It's not particularly stale, but obviously it allows us to show that in terms of the actual solution. We can, in terms of the results, some of the things that we can do, for more sort of to make it more presentation based, we can actually look at where it says CFD view type. We can go to a rendered view. If I apply that change, you'll now see that that's applied that information with a rendered view here. So I can zoom into the model, and I could say show where the areas are with a rendered view. So it allows us to make it a bit more presentation based. But obviously that's not essential, but it can be a useful presentation tool as well in terms of getting that across to your clients. So there are ways as well of adding additional information in terms of HVAC and looking at HVAC analysis, but I'm not going to go into that here. This has been largely a presentation showing you natural ventilation and how that would be done. There will be a future seminar or webinar on showing how we can do sort of HVAC-based analysis. So hopefully I've gone through that, and it's shown everybody the way that we can carry out some simulations in EnergyPlus. We can import those boundary conditions into a CFD model, and then we can carry out some analysis on those CFD calculations and look at the various ways of showing that data. So I'm kind of hoping that that's given you a flavor of what can be done. I don't know if anybody's got any questions that that they would like to ask.